Let's take a look at how you might have solved the population growth problem. Recall that in this problem, your task was to write a program in C that was able to figure out how many years it would take to go from some starting population size to some ending population size according to some mathematical formula. So inside of population.c, you'll see that the first thing we wanted to do was prompt the user for a starting population size. To do so, we could use the getInt function from the CS50 library, saying getInt start size. Let's get the starting size for the population, storing that value inside of start. But recall that we couldn't just accept any integer as the starting size. We definitely didn't want to accept 0 or a negative number, but we also didn't want to accept numbers that were less than 9. We needed the starting population to be at least 9 to make sure we could start to actually grow this population. So in order to continually reprompt the user for input until they provide us with a valid input, we here used a do-while loop, where we're going to repeatedly prompt the user for a start size as long as start is less than 9. If start is less than 9, that means the input is not valid, which means we need to prompt the user again. And so this loop will continue running until we ultimately get a value for start that we consider to be valid. After we've prompted for the starting population size, we next need to prompt for the ending population size. And here too, there's very similar logic. We want to use getInt to prompt the user for an integer, but we also want to make sure that integer is valid. In particular, the ending population size can't be less than the starting population size. If the end size is less than the start size, that's not a valid input, and so we need to reprompt the user. So here too, we can use a do-while loop. We'd start by declaring an integer called end, and then we're repeatedly going to prompt the user for input, end equals getInt end size. And if end is less than start, that means the end value provided by the user is not a valid integer, which means we need to reprompt the user for a new value again and again until they provide us with a valid end value. Once we have a valid start and end value, we now need to figure out how many years it would take to get from the starting population size to the end population size. In doing so, we're going to want to keep track of how many years have passed. And anytime we want to keep track of information inside of our computer program, it's often going to be helpful to have a variable to do just that. So here, we define an integer called years and set it equal to 0 at first, because initially, no years have passed so far. But we're going to be updating that variable in due time. Now, we need to keep updating the population size until we get to the end population size. And anytime we're doing something again and again, it's often going to be helpful to put that code inside of a loop. So while start is less than end is going to repeatedly run some code as long as the starting population hasn't yet reached the end population. Once the start population does reach the end population, then this condition will be false and will exit the loop. What does the loop do? Well, here we have a line of code that updates the population, updates the value of start based on the mathematical formula for how many new members of the population we're gaining and how many members of the population we're losing. Recall that per the formula, every year we gain start divided by 3 llamas, if we started with start llamas, and we lose start divided by 4 llamas. So by having start plus start over 3 minus start over 4, we're able to calculate the updated value for the population size. Recall, too, that division of integers in C will automatically truncate for us anything that shows up after the decimal. So if we end up with a number like 2.8, for example, we'd cut off the 0.8, and we'd just be left with the number 2, which is the behavior that we expect for the program. The other thing this loop needs to do, though, in addition to updating the population size, is to update how many years have gone by. We've updated the population once, which means one additional year has passed. And so I've included years plus plus here to mean one additional year has passed. Let's increase the value of the variable years by 1. After this loop is over, we will have reached the end population size. And the variable years will now store the number of years that it took to get us from that starting size to the end size. So ultimately, we can print using printf years colon, and then %i to stand in for some integer here, printing out the value of years. All in all, once we compile and run that program, we can provide as input some start and end population size, and our program will tell us how many years it took to get from the start to the end size in population. My name is Brian, and this was Population Growth.